Hello, this is the Genuinely Approachable Sudoku for the 8th of March 2024. It is Fortress by Clover featuring, well, fortresses. So yeah, let's take a look at the rules of this puzzle. Normal Sudoku rules apply, so place the digits 1 to 9 in every row, every column, and every 3x3 box. Digits in grey cells are greater than all digits in orthogonally adjacent white cells. So this digit, for example, is greater than those two digits. If this was a 4, then this could be a 3 or it could be a 2, as long as it is greater than this cell. Now note that this only applies to adjacent white cells. So for example, those two grey cells there, they do not have any relation. They could be one greater than the other or the other way around. So yes, with that, let us just begin solving. Alright, because this is generally approachable, I actually wanted to change things up a bit and decide to actually explain tactics in more how should I say this, seriousness? Explain tactics in sort of more a more, you know, in detail fashion. So we're gonna not try and speed solve today. I will still speed solve your classics, but I don't think I will speed solve these, so I can explain stuff here. So let's start with how we can look at fortresses. Fortresses basically imply every grey digit is larger than a white digit it touches, right? And so we want to find some that are bounded on a higher level. That is, we want the white digit to be as high as possible, or the grey digit to be as low as possible, because that gives us the fewest number of options. For example, this 7 over here, and this grey cell that is larger than 7, is constrained because this cell only has 2 options. It only has 8 and 9 as options because only those digits are greater than 7. The similar thing happens here where those cells can only be 8 and 9. And now this forms a pair in that those cells must contain 8 and 9 and therefore cannot contain anything else. This 8 means that must be 9, and this 9 means that must be 8. Now because the digits 1 to 9 in the box, those three digits are all you know, we know those digits. Those digits are 2, 4, and 6 basically, because those are the last digits we have not used in this box yet. Now I can place one of those 3 digits in the box, and that digit will be a 2, because we want to find small digits that are in grey cells. We know that 2s here cannot be there because those 2s are not greater than 3, and therefore those cannot be 2s. The only place 2 can go in this box is up here, which is accurate because 2 is in fact greater than 1. However, 2 in a grey cell also affects whatever else it's touching, and so that digit also has to be 1. So yes, we can do the same thing for a lot of other things as well. For example, the 6 here might be useful because those digits are greater than 6. They have to be 7, 8, and 9, but because of the 7 here, they cannot be 7. They are therefore either 8 or 9. We can do the same for the rest actually. In fact, that is also pretty constrained. It is also 8 and 9 because 5 here, those digits must be greater than 5. Now our options are 6, 7, 8, and 9. However, 6 and 7 see both of those cells by regular Sudoku rules. So those digits cannot be 6 or 7. They have to therefore again be 8 and 9. Can we do that one more time? Not necessarily, but this 8-9 pair will resolve whatever we have here, which will proceed to resolve whatever we have here. Now this 5 means those digits are greater than 5. It is no longer 8 and 9 because that digit sees 7, 8, and 9. So the only other digit greater than 5 that we can place here is a 6. This digit similarly cannot be 7, 8, or 6, so the only other digit greater than 5 would be 9. Now those digits form a triple, which is what we used here to say that there are only 3 digits left in the box. They have to be 2, 4, and 7. And actually the 7s here resolve that for us. Those cannot be 7, so 7 goes here. This 2 also resolves this 2, 4 for us, which does that. This 2 now, again, is a small digit on a grey cell, so this must be a 1. Well, not so, it's just, if it's small, we look at it. We can continue with those digits, which must be 2, 4, and 5, which sounds a lot like my actual username. 2 and 5 means that it cannot be 2 or 5, it must be 4. 2 cannot be here because 2 is not greater than 3, so 2 goes there. And therefore this digit is a 1. This digit must be a 5 to finish the box. Now those digits are 2, 4, and 7. This digit cannot be 2 or 7, so it must be 4. This digit cannot be 7, so it must be 2. And that digit is therefore 7 to finish the box. 2 means this is a 1. So yes, we're almost done with the outside ring. We can fill in a few more things, like this for example is just a 3 to finish the column. This digit is either a 4 or a 6 to finish the column, but because of the 6 in the row, this must be a 4, that must be a 6, and that must be a 4. We could have also done it by saying that this digit is greater than that. So this cannot be 4, otherwise this would be 6, which breaks. That digit is a single 3. That digit is also a single 3. Which means we can actually place 3 in this box, because we have a lot of 3s going on here. None of those digits can be 3. 3 must go up there. Ooh, 1s also do the same thing. Those 1s see all those cells, so 1 can only be here. Okay. We could do a lot more stuff. For example, every single row and column highlighted here are all triples. So we can painstakingly put digits down. So those are 2, 4, 8. Those are 5, 6, 9. Now obviously we don't have to do this. We can do this by regular Sudoku, but it is something that I am okay with doing, so I will do it. Those digits are 4, 7, and 9. It actually is a good exercise as well because it's 2, 5, and 6. It does let you read numbers better. So those digits are 5, 8, and 9. And those digits are 2, 4, and 6. Now we can start resolving everything. 6 here, for example, removes 6 from those cells. 3 removes 3 from nowhere because 3 is already in there. 7 removes 7s from those cells. And this 7 actually does that as well. Those 7s remove 7s from those cells. So now those digits are forced to be 7s. We can do the same as well with other digits. For example, 8 means that cannot be 8. This is admittedly pretty messy, but it is what I have absolved to do, so there we go. Now this digit actually is again touching a white digit that is pretty large, so this is either 8 or 9. Same as the original trick we did first. This 4 means 4 is no longer in that cell. Right. Oh, and yes, another trick that we can do is to say that 1 can never be in a grey cell and 9 can never be outside of it. That is because nothing is greater than 9 and nothing is smaller than 1. So yeah, those are 2 forbidden digits in those positions. For this, we don't need to touch the 1s because 1s resolve themselves very easily. The 9s that we can remove from those cells, those cannot be 9s. In fact, this cannot be 9 either for the exact same reason, so it must be 4, meaning that's a 9. Which means that is no longer 9, that is 5, which gives us all of this. 5 means that is no longer 5. 4 means that is no longer 4. 8, 9 here means this cannot be 9, that must be 8, which resolves all of this. This means 2, this means 5, this means 9. And we're basically done at this point. We do have some stuff left, but not too much of an issue. This 8 means this must be greater than 8. That must therefore just be 9, which resolves this 8, 9 pair. This 8 resolves this 4, 8 pair, which in turn no longer really does much. But this does form a triple in the box, which has to be 2, 4, and 5 again. Now 4s, look at those cells. So those can't be 4s. 4 can only go here. 5 here resolves the remaining 2, 5 pair. And we're almost done. This 2 means that must be 6. And this 6 means that must be 5. The 6 up... Oh no, the 4 here resolves this 2, 4 pair. No, 2, 4, 6 triple. What am I saying? This 2 means that is 5. This 6 means that is not 6, so that's 2. Therefore that is 6. There we go. Solved the puzzle in 8 minutes and 28 seconds. Now of course admittedly I could have done this a lot faster. You know, not that I'm bragging that I could, I'm just making this a lot awkward, but I did in fact want to just go through the tricks that you can do with this kind of stuff. Maybe every single video that I do on General Approachable Sudoku should be like that, instead of me just talking about what I should be doing to make things faster. Right, so yeah, we're gonna take a more educational approach on things. So I hope you enjoyed this video. I'll see you guys next time. Bye bye.